So this is our webinar transitioning to open. It's a case study in General Chemistry OER Adoption. And so just so that you know, if you don't want to be forever on YouTube, you should blank out your ability to be seen on the camera. And we are going to record this and post it. And we would like to also license it open Creative Commons. And so these are some of the folks who've been involved with this whole process. So we have Deanna Habel Rodriguez with chemistry, Ezra Depperman, also chemistry at UNM. Jillian Stafford, I don't think she's here, but she's also taught with these materials. Joseph Ho, and then Stephen Cabanis. He's also here and he is working on a different chemistry book, but he's been behind, working with everyone to move chemistry toward open educational resources. So this is going to be our agenda. We're going to talk a little bit about open educational resources at UNM and in New Mexico, and then we'll cover the adoption of chemistry materials at UNM. Folks will talk about the materials that they've created and what they've needed to modify or supplement. We'll ask y'all for questions, and then we'll transition to the chem lab. And then Joho will talk about the materials that he's made, modifications, and then we'll end with a summary of resources and other things that you can use to get started if you'd like to transition to OER. So I wanted to start off just to give you a little bit of context for why we're doing this at the University of New Mexico. We have an Open Educational Resources Initiative, and it started officially in 2022. But for years before that, there were people working on OER, trying to move it forward. And then I came on in 2022. And one of the goals was to kind of spread OER across the state, not just at UNM. We started with UNM, but now we're also doing outreach across the state. So at UNM, we also in 2023 applied for a grant from the Fund for the Improvement of Post-Secondary Education through the Department of Ed. It was almost $2.125 million. But part of this grant was to create a consortium of colleges in New Mexico that are supporting faculty development of OER. And so at UNM, we have different people working on OER in IT, Elisha Allen, and then Center for Teaching and Learning, Stephanie Spong, Sammy Williams, who was hired on the grant and is our program coordinator. I am the PI. And then we're also working with Central New Mexico Community College, CNM. And then Christine Gosshorn is the PI over there, and then Santa Fe Community College as well. And so what we're doing is we're giving support to faculty to create and adopt OER because it can take a lot of time. And then also it can be a little bit confusing at first, but it's really not as hard as it might seem if you're new to OER. We're also working with UNM Press to create the materials. So I'm going to transition to Ezra and Deanna.
All right, so I want to tell you a little bit about how our lecture sections of general chemistry for STEM majors are set up. We split our class time where we say maybe take half of the class time and do a lecture with examples and so on. And then we reserve maybe half of the class time for students to be active and do worksheets in small groups of 3 with support. And the support is instructors, teaching assistants, and other sort of course assistants, peer learning facilitators, walking around and working group by group with people, with students. And the reasoning behind that is, rather than us talking for 50 minutes, we really want to give students the space to formulate questions as they work step through a problem that is posed to them and actually get them answered. So like the support team is right there, the instructor and the teaching assistants are right there with the students, so might as well make really good use of class time to get the difficult and sort of tricky parts answered and get support with that. But that brings with it the need of some preparation. If we're cutting out half the lecture time, we want people to do some initial exposure to the new vocabulary and some of the concepts. So we're going to ask them to do some reading before class and turn in a reading quiz with basic questions, sort of like the kind of questions that you should be able to answer if you read through the material, but you certainly didn't delve into it very deeply. And after class, there's still sort of the traditional homework and help sessions. Turn it over to Ezra.
So, why would we go to the trouble of selecting a new textbook? And the answer is, since we're an institution that serves people from all socioeconomic backgrounds, we really wanted to lower the barriers. And so an open textbook means less money per semester that the students have to pay. And then we also thought we might want to be able to customize the textbook to reflect exactly what we want to teach. And finally, what we had been using was inclusive access, where the students would be billed a certain amount by the bursar's office per semester. And the unfortunate thing was, after 2 semesters or 4 semesters in some cases, their access to the book goes away. It's not necessarily a bad consequence for someone who's going to go to medical school, but if they're a chemistry major, they may wish at some time in the future to refer back to their chemistry textbook, to their general chemistry textbook. And so the open educational resources, you have access as long as you wish. There's no limit. And when we looked at the textbook, the OpenStax textbook, we found that it's a pretty high quality text, just able to stand up to any of the texts that are behind a paywall from any publisher that we encountered. So at UNM, in our General Chemistry 1 and 2 sections, since it's a Gen Ed course, I think the standard for the state is it's Chem 1215 and Chem 1225. We have 4 instructors, somewhere around 800 students per semester. One thing that we really like about OpenStax is that it comes with a course cartridge that you can download for your LMS, and that includes links to the latest edition of the textbook along with some great interactivities. But one thing it doesn't have that a publisher's textbook does have is a question bank that allows the students to answer questions as they're reading. So to that end, we created our own question bank using Canvas, but we can share that, and it's readable by any learning management system. And if anyone wants access to that, we are happy to share it with them. Just give us an email. Another thing that's really cool about the OpenStax textbook is it has links to PhET simulations. I don't know if you guys have used PhET simulations, but very cool simulations that are really powerful teaching tools and learning tools. And given the way students are these days, given their short attention span, we elected to stick with the live version of the textbook because of the links, right? So the students have a link, they could just click on it and immediately go to the relevant section of the textbook, rather than having to open a PDF in a separate program and then navigate to a particular section. Another great thing about sticking with the live version of the text is it gets updates. And I personally found an error in one of the example questions and submitted it to the system, and within a week they had corrected it. So they're very responsive.
Just one more thing, sorry. The PhET simulations aren't just like, oh, this is a great high quality resource. They're actually linked in the OER text itself. So the actual chapter and sections in the OER text point students to the simulations. And you may choose to reinforce that if you like those simulations.
So we wanted to have questions for our question bank, for our reading quizzes, right? This is the before class stuff that aren't too difficult, that are given in different formats so you can see. We have some matching questions, we have some multiple choice questions, some numeric entry questions, some multiple response questions. Maybe not as visually stunning as you get with publishers' questions, but doing this was a great opportunity for us to think about exactly what we want students to get from the reading and to fine tune it, which is something that you don't get to do as much with a publisher's textbook. So we have some survey data. It's not a huge number so far. This is a poll about the questions that we wrote, and the amount of people who strongly agree with this was really impressive. They thought that it was a good level of difficulty for something that they have to do before coming to a lecture. We also had a survey about how they felt about the text, and the vast majority of them like it. We didn't have a huge amount of people saying they love it, but we've never had that for any textbook anyway.
I actually remember the like specific questions, if that helps. So we have a more formal survey that we may be able to share later. Jennifer does. But we just sort of gave a poll to our students within the class and got 136 students to actually reply out of the larger sample of several hundred. And the first question was, do you think this book presents the material at the right level of difficulty? And about 79% of the students either agreed or partially agreed that the book presents the material at the right level of difficulty or detail. And the second thing we polled the students about in this sort of informal survey was, do you believe the book has enough examples? And about 74% of the students thought the textbook, the OER textbook had enough examples, either agreed or partially agreed. Yeah.
Okay, and then as far as feedback from the instructors, we didn't have any big problems with it. Speaking for myself, I find this textbook is able to stand up against any publisher's textbook. And, they all have their strengths and weaknesses, but I think this one is very good. We did have some issues with alignments because the sequence is not exactly the same as the previous textbook we had been using, which was Chang from McGraw-Hill. If you could advance to the next slide, please. So I just wanted to highlight one difference that we were actually able to leverage. So our previous textbook first taught molar mass and the mole concept. So you're interconverting mass and moles. And I know a lot of you are chemistry educators, so you know what I'm talking about. And if you're not and you want more detail, just pipe in at any time. And then they teach stoichiometry of pure substances. So you measure the mass, or you're given a mass, and you use the molar mass to convert that to moles, and you use a mole ratio to convert that to moles, and then you can use molar mass again to get the mass of product you're going to obtain, for instance. Then our previous textbook goes on to introduce aqueous reactions and solution stoichiometry. So we drill the students about how to get moles from the volume and the concentration. But then when we try to get them to do solution stoichiometry, they're stuck with the stoichiometry of pure substances. They're trying to use mass and molar mass. And so they're taking the volume and using the molar mass to get the number of moles, right? They're stuck in that mass to moles to moles to mass motif. So OpenStax does things a little different, and at first I thought it was so inconvenient when I was looking at a side-by-side comparison of the table of contents. So first they give you molar mass and the mole concept. But then, before you learn any stoichiometry of pure substances, we go to solutions and concentration. So the first thing we're focusing on is taking a measurable quantity, either a mass or a volume, and converting that to moles using the molar mass or the concentration respectively. And so then we go ahead and we introduce stoichiometry, and you can do stoichiometry of pure substances or solution stoichiometry. And then stoichiometry is more like a measurable quantity can be converted to moles, which can be converted to moles, which can be converted to some other measurable quantity. So that's more like how we want the students to be able to do it. All right, and I see that we're almost out of time, so Deanna, you want to take it away?
Yeah, I really like that example, Ezra, because the alignment is going to be some work. It's not too bad, but sometimes it's an opportunity to sort of think about how things are taught. And next slide, please. So we started thinking amongst ourselves, the chemistry colleagues in the department here, about how students use the book nowadays. There's one line here that says, the top line, read the book and take notes, then do the pre-class quiz, then come to class, then do the homework. And then there's the second version here. How about what some people might do, and that is like maybe attempt the homework, see if they can do it, and only when they come to the point where they can't answer the question do they then go and consult the book for the first time. So we're thinking a lot of students nowadays have become just-in-time learners. And the caveat here is they'll consult the book to see if they'll find something useful to answer that question. And if that's not immediately coming out of the book, maybe they'll go and find a video online and sort of skip reading the book altogether. So for whatever that's worth, we're going to keep that in mind. And I think we found that we might place some extra value in making the book very accessible with the homework and pre-class pieces. For example, having reading assignment links to the specific sections as opposed to just sort of telling people to go find the chapter on their own. And some homework systems also direct link to OpenStax questions or OpenStax reading questions within the homework question. So we're just sort of trying to make sure people will actually utilize the book and making it very convenient to do so, so that people don't just immediately default to online videos. Next slide, please. And we just wanted to tell you that we didn't do every part of this in the very first semester. So we didn't just all simultaneously decide we're gonna realign our entire, chapters and redo all our reading assignments and re-import all our links and do a new homework system. We decided to phase it in. So in the first iteration, which sort of comes to an end at the end of the spring, we did the alignment for the chapters. We created new pre-class reading questions, which Ezra already mentioned. We're very happy to share with anybody who can use a Canvas cartridge. And then we took some notes. So in this little small example here, you can see the blue column is the notes. The green column is sort of the lecture content. And look, on this particular example, I put myself a note that I might want to put a figure of a resonance hybrid that shows the dotted bond line notation because the text didn't have that. So what our plan is for the second iteration is to follow up with these little pieces, either by posting them as supplemental materials on Canvas or submitting them to the OpenStax to see if they'd be willing to incorporate it, and re-evaluating the homework system. So we sort of spread the effort over 2 stages, and I hope that just sort of makes it easier for people to buy in because, it's work. But we think it's worth it. So I think we've arrived at the point where we're gonna see if you guys have any questions that we might be able to answer.
Don't everyone jump at once.
And you guys have been working on this, like talking about it. Like first, the whole department moved over. In 2022 is when I first started talking with you all, and then it took a little while for everyone to be on board with it, right?
Yeah, I think the initial sort of concerns were, is the open textbook going to be high enough quality to really support our students? We don't want to support our students within something that isn't going to be quite good enough in order to save them 50 or $100, right? And I think we sort of arrived at the point where it's the second edition OER textbook. It's very nice. It has a good coverage. It has lots of nice figures. It has the PhET simulations as sort of the interactive simulation piece. So I think we believe that we're not shortchanging our students. We're gonna opt with a commercial homework product to supplement the OER text, but we're trying to find one that is low cost and high quality, and that sort of aligns really well with the OER text. So that's sort of work we're doing right now. And I think that kind of addressed some of the things that people had concerns over with the OER. And I think the fact that we're phasing it in 2 iterations, sort of doing half the work and then the next year do the other piece, the homework piece, makes it a little bit more palatable for colleagues, I would say.
Yeah, anytime you're going to make a big change, do one thing at a time. do manageable changes one at a time. Don't try to reinvent everything at once. That's just overwhelming. I wanted to say that one tool that we found very helpful was to take the table of contents of the textbook and put everything into a spreadsheet, which wasn't just readily available. It took a little bit of doing, and I'd be very happy to share that with anyone who wants it. But that's an easy way to check for alignment if anyone is interested in adopting this textbook. So save you guys a little bit of work there if you would like it.
Thank you. Should we move to Joe?
Thank you.
So,
Well, thank you for the opportunity I can talk about my journey in laboratory teaching. So let me give you a short background. So of course I have the same number of students as Ezra and Deanna every semester, and sometimes even higher because students are taking the lab and not the lecture. So I started with a very traditional lab approach, which is the cookbook. I think everyone is familiar with that, even you are not in chemistry, right? So when you cook and you find the recipe and just follow the recipe. And that's a cookbook approach and very traditional. And I was not satisfied with that 30 years ago. So I start to look into different ways, and almost every other year I make changes until we change our teaching in the lecture for active learning. And I start to think about, how about the lab? How do we do the active learning in the lab? The lab should be active learning by its nature, because we ask the students to, test on their ideas, and in the lab, you can have the hands-on. That's active. However, we made our lab not active by giving them the cookbook approach. And therefore, I say, okay, let's recover the nature of the laboratory work. So I started with letting the students design their experiment, design their procedures. And I found that is difficult because they don't have enough time. So when I start to think about what's the other way, next slide, please. And I found this approach is naturally match the laboratory work, and that's called the course-based undergraduate research experience. So when we say research, students are frightened, right? So I don't know how to approach your research, but we bring the research experience into the course, and in my case, that's the laboratory. So I bring the research experience to them. So I say, well, I need to give them more time to think about how to design the experiment. So I split the experiments into 2 days or 2 weeks. And the first day they have to design, and second day they can use their design to carry out the experiment. So that's the type of research experience I bring it to them, because that's every chemist do in their laboratory. And this particular approach is called the CURE. And the UNM has its own version called expanded CURE. And that, if you have a question, I can explain more about that. But on this slide, you can see that this is the major structure of the book I'm writing for the eCure. And I started with the lab safety. And then I explained this whole process of how chemists work in the laboratory in the basic best lab practices. And we usually spend 2 weeks to explain this whole thing to the students in the semester. And then I will lay out the project. I will help the students to go through each step of the practices in this book. And I also provide the instructors' resources in this book. So whoever interesting to adopt to this approach, you'll get a lot of information that I struggle with in the past 20 years. And hopefully that will be helpful. Next slide, please. Okay, so this is a very, the table of content of my book, and it has totally 10 experiments. Now, with the split of the design from the data collection in my lab, I can only do 5 experiments per semester instead of 10 or 12. So with 10 experiments in this book is good for 2 semesters. So it is good for the entire year of the general chemistry program. And now notice the appendixes. I have put many modern chemistry instrumentations, approaches in the appendixes for students' references. And with the goal that I expect the students to be able to use some of the methods I mentioned there. So that's a general view of the books I'm going to complete by the end of this year. So if you have any question, I will be happy to answer.
So we need to figure out where to put the lab manual so that people can access it like out on the web. But if they want to get a hold of it, they can email you.
Of course, and I understand, the adoption to the lab book is relatively more complicated because it depends on what instruments, what equipments, your lab setup, who is teaching it. And that's why we always see a customized lab notebook in the market. So by thinking of that, I do have in the instructor's resources, I do have lots of suggestions about if you have different typical setup in your lab and what you can do and what you can modify the experiments we have in the book.
Anyone else have questions about how this whole process of changing over to OER?
And I'd like to add one more thing. So, there are many experiments I put in my book that requires expensive instrumentation. We have the resources, for example, MMR, mass spec. We have a mass spec facility. We do have some capacities to help out if you want to send a sample to our facility, and then we can analyze it for you and send it back, the result to your students. This semester, I'm helping a high school chemistry lab. They are sending 16 samples of what the students synthesize. And we use different instruments to analyze it for them, and we send the result back to them. This whole process benefit different levels of students because I have undergraduate students involved in this, analyzing them. And I also have graduate students that are helping the undergraduate students to do those analysis. So this really help everybody. So if you are interested, for example, if you want to do something that you desire to use a different instrumentation, contact me. Maybe I can help you out with the analysis.
Joe, are you able to offer that free of charge to the high school?
Only for this case. I don't know. In the future, there might be a change of the, how we run about this, but basically, if you go through me, and chances are we can get some of the analysis free.
Thank you. So this is our resources slide. So I just want to say that we started this journey like about 3 years ago. And I mean, it takes a while to move over to OER, but it's really worth it. We're also interested in working with other colleges in the state. We have our consortium with 3 colleges right now, but we definitely want to work with more. Part of the goal of the grant was to like focus on these general education courses because we all have the same outcomes and we have very similar students. So hopefully like these resources could help other colleges too. But did you all have any other information or resources that you'd like to share?
I have a question for the group.
Go ahead.
So when you made your transition from a publisher textbook into OER, how much time did you have to invest into setting up the curriculum the way you wanted it before you made it publishable to the students?
I can field that. So, can you guys hear me?
Yeah.
Yeah, so I actually decided between the spring semester last year, so spring of 2024 and summer semester 2024, I went ahead and just implemented. So it was a hectic 2 weeks between the spring semester and the summer semester, but I was able to, using that spreadsheet that I talked about, I was able to align it and use the existing homework platform and make it happen. It was a little bit hectic in that I got started writing the reading quiz questions in that 2 weeks, but I didn't finish, for all of the lectures. So I had lots of nights and weekends where I was writing questions. Yeah, building the plane while flying it. Exactly, Jennifer. Putting those questions together into the reading quizzes and then, finding that I had made a mistake or something and having to go back and correct that. The students were very, very helpful with that. But having done it, I think I'd be able to offer, help and resources to make anyone else's transition a little bit smoother if you're interested.
Yeah, and I I was also a little bit leery about, from the initial plan of, oh, we'll do this, and then actually doing it, what are the pitfalls? I have to say, other than maybe 2, 3 places where the OpenStax sequence differs a little bit from what maybe various commercial textbooks use, there wasn't too much that didn't align well. There was like 1 or 2 little sections where I'm like, oh, this is in a much later chapter and I'm used to seeing it earlier, but it was minor. So I think it's sort of, other than writing all the pre-class quiz questions, which you may or may not need, depending on how you use the book and which we'll be able to share if you want them. I think the alignment piece itself wasn't too bad. Would you agree with that, Ezra?
Yeah, it was not bad. Not bad at all.
If you're a chemist, if you're teaching general chemistry, we can absolutely share it with you where the pieces are that aren't quite where you think they might be. The 2 or 3 that I mentioned, we have a little list and we can totally share that.
Like compared to changing to like say you were to change to a different chemistry book published by a publisher to another chem book, the extra time that it took was just creating those questions, or was there other extra work?
Just the questions.
That's pretty
Agreed.
good.
Yeah. I think Ezra already mentioned it, but I'll just say it again. OpenStax has a cartridge that is importable into the Canvas course that spits out links to every single OER text section. And you still have to manipulate it a little bit, but that's great, right? Yeah, it's very convenient.
And they have cartridges for all the books that they create too. And it's all peer reviewed.
Yeah, I was going to add into that. About 8 or 9 years ago, I did this with an anatomy class in high school and took a college anatomy text from Rice University on OpenStax and made it into a high school class. So you have to learn how to pare things down. I mean, I just was asking because we have teachers that ask how long does it take to build things at Doñana Community College. So
Right.
it was, the point of the question is really to find out if chemistry took longer than, in my mind, how long it took for anatomy or how long it will take for a math class.
And what's the verdict?
We're just starting on the process right now. We're introducing that concept of this just from based on this meeting here, and my perspective after building one myself, the cartridges are great, and there's also a bunch of resources that are in these books that you can go into the teacher resources and get question banks from them. So different books have different amounts of question banks. I just wanted to throw that out there.
Yeah, no, we the question banks for the chemistry textbook, it has a lot of really great multiple choice questions. And we just wanted, again, it would take some doing to import them into Canvas. And so we opted to write some of our own just to have sort of diversity in question format and also to be able to really focus at a hyper focus level for exactly what we wanted to achieve from the reading.
I've heard of some teachers, not chemistry, but some teachers using AI to help them build the supplementary materials for their class. I don't know how helpful that might be for you all.
Actually, it's getting better and better. 6 months ago, I would say don't do it, but now I would say use it as a starting point and then, go through and double check things. But it's pretty amazing how powerful those tools are becoming.
On the general subject of chemistry versus, say, math or anatomy and whatnot, one advantage that we have here is that these general chemistry textbooks from half a dozen different major publishers are so similar to each other. Changing texts frequently is not as much work as it would be if the textbook authors were a little more adventurous. It's the same set of chapters. Most of the stuff is in the same order. The difference tends to be in writing style and numbers of examples and worked problems and whatnot. Changing textbooks is work, but I think chemistry is probably an easier discipline to do it in than at least some of the areas of biology that I've looked at where the textbooks are not as uniform.
Yeah, and chemistry has been OER for a long time too, in technology years.
I incidentally heard some of my students, even on the surveys, mentioned that they used OER in their math classes and liked it. So it sounds promising.
Which math classes? I want to talk
I
to
don't
those
know. It's an
teachers.
anonymous survey, so I can't exactly follow up. It may or may not have been at UNM.
Okay.
Yeah.
And I'd like to add that, building a OER for anything, including chemistry, you don't have to stick to one book. You can look for other books, and as long as they are OER, and you can get the best from different books and put it in your course.
Yeah, I mean, like if you're starting from scratch, I would say probably a couple of years to get it done. If you're also teaching at the same time, like that's kind of the pattern that I've noticed with faculty. And there was also a study that said like transitioning a course could take something like 180 hours or something like that. But it just depends on what's already out there. Through the grant, we were able to support the faculty who were creating this material to compensate them for their time. And so that's what we also want to do. Through the consortium, we're working on figuring out how to do that with other colleges as well.
So you're saying, Jennifer, that the grant has money to
No,
no?
we have to find other money.
Okay.
But we're looking for other money. We're looking for partners and money. So
And I guess I'll just add that we kind of made a choice, right? OpenStax will give you an editable file if you request it as an instructor, where you could delete, add text, or add a figure that you really, really want to have there that you think is crucial. Or you could change the alignment of the sections if you wanted to, right? If you really had your heart set on it. It's just that when you save that, it becomes a PDF that you then would like disseminate to your students. So that's one route to go. We went the other route. We used the live text that is in whatever order it is and has all the links pre-made, because we found it wasn't that far off from what we wanted. And now we'll go back and sort of supplement the little changes by posting them on Canvas as supplemental material. Or maybe we'll try submitting some to OER and see if they're willing to throw in some of our favorite figures in the text. But yeah, there's like two routes, right? Like you either get the text, you edit it and republish it as your own version, and then you don't have to worry about alignment because then you align it the way you want it, but it is some work to do that, and then you won't benefit from like the live version with the links and updates and so on.
and the chemistry OpenStax textbook is available on so many different like repositories too. There's people who've taken it and adapted it for their specific populations too. So if you do a search, you can find a bunch of different cool things that people have done with this one same textbook. I'm going to put the link for our consortium website. We have 6 books on there now, not chemistry, but if you want to check out what we've been doing, that's out there. Anyone else? Questions? Let me see. Oh, here's our last slide with all of our emails. If you would like to get a hold of anybody, like Deanna and Ezra said, they are happy to share their quiz. What is it? Question banks?
Question banks, yeah.
And that would cut out a lot of time with the adoption process too. No more. If we don't have any more questions, I'll go ahead and just say thank you for coming, and thank you to our presenters for all of their hard work and also for volunteering to present this on a Friday afternoon. Thank you.
Thanks for putting this together.
And Sammy, thank you, Sammy, our timekeeper extraordinaire. Awesome. Thanks, everybody.